Hello and welcome to this episode of Math with Martinez. We are in our fourth episode in our 8th unit of pre-calculus titled Trig Functions, and this lesson is all about reference angles. So let's go ahead and dive on in. The reference angle in a diagram like you see here is the acute angle that is formed by this terminal side of your angle, call it theta, in standard position and the x-axis. So theta is this angle that is starting at the initial side and then terminating right here. That's your angle theta. But your reference angle is this little angle, which we often use alpha to denote. Your reference angle is right here. It's what is created by that terminal side and then dropping down to your x-axis. Dropping down to your x-axis from that terminal side. Or I guess it could be going up to your x-axis. But always, 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 and this is what I want to highlight with you guys, it is always formed by the terminal side and the x-axis. So let's go ahead and see if we can correctly identify the reference angles for these examples below. What we're going to do is sketch each angle theta, and then we'll find its reference angle and call that alpha and state just how many degrees or radians that is. So let's go ahead and get started. We're going to sketch an angle that is 150 degrees. Now 150 degrees, which quadrant is that going to be in? Quadrant 1, 2, 3, or 4? Yeah, that's going to be in quadrant 2. In quadrant 2. Oops. I'll be right about here. That is theta. Now what we want to find is its reference angle. The reference angle is going to be the angle from the x-axis to that terminal side. We'll call it alpha. So let's figure out just how many degrees are in that little angle there. Well, if I were to measure from the x-axis all the way to here, how much would that be? That axis, that negative x-axis represents 180 degrees. And if we subtract our theta from it, it'll give us that little remaining amount. So subtract 150 from it, and that means that our reference angle is 30 degrees. There you go. Now let's look at this next one. 315 degrees. In which quadrant is that angle going to terminate? Yeah, it's in this final fourth quadrant because right here, this is 270 degrees, and this right here, if we went all the way around, would be 360 degrees. So our alpha is always from the terminal side to our x-axis. It is this angle right here. This is alpha. So how will we find that? Well, like we did previously, we can take away from a full revolution our theta amount, which was 315 degrees. And that is going to give us, what is that difference? That is 45 degrees. There you go. Now this last one is a little bit different because we instead have a negative angle. So if I rotate negative 240 degrees, from here to here is 90, 180. So it's got to be here in our second quadrant that our angle would terminate. And so our reference angle is going to be from our x-axis to that terminal side. This is going to be alpha. So just how much is that? Well, think about this with me. It is just the remaining amount to get to that positive x-axis. Or you could say take away from 240, take away from 240 degrees, which is how much we rotated. I know it's negative, but that quantity, that amount, take away half of the entire rotation, or what I'm saying is take away this part from all of this, take away this, and that'll give you your little alpha reference angle. What are we taking away? We're taking away 180 degrees. And so how much does that leave us with? What is that little reference angle? 60 degrees. There you go. Now, shifting gears and looking at radians. It may be helpful to kind of take a moment here and sketch in the margin for yourself. Just a reminder what each of the axes will be in radian measure. Remember that this is 0. A full revolution is 2 pi, which means half of a revolution is 180. Half of that would be pi over 2. And what is 270 degrees is actually 3 pi over 2 radians. So this kind of helps us to think this through. So let's go ahead and begin. 5 pi over 3. 5 pi over 3. So think about that fraction, 5 over 3. 5 over 3 is more than 1. 5 over 3 is going to put you almost to being a full revolution, because a full revolution, think about this with me, a full revolution would be 2 pi, which as expressed as thirds, it would be 6 pi over 3. So what that means here is that if we're at 5 pi over 3, we must be all the way in this fourth quadrant. We rotated all the way to here. That is our 5 pi over 3. And so what we're curious about is just how much is here? How much would our reference angle be? Well, it's just that third that is lacking, right? Because a full revolution is 6 pi over 3, which simplifies to 2 pi. That little angle right there is 6 pi over 3 minus our 5 pi over 3, which is just pi over 3 radians. There you go. Now let's look at 7 pi over 6. 7 pi over 6. Okay, so this is going to put us in this quadrant right here. The reason being is, if you think about this, 6 pi over 6 is the same thing as just pi. So what have we done? What have we done here? We've gone 1 pi over 6 beyond our pi. This is pi radians. So we've gone a little bit more beyond that. How much more have we gone beyond that? Well, 7 pi over 6, take away from that all of this amount, and that'll give us what we're looking for. That's to say, take away 6 pi over 6, which is just that half of a revolution. And that gives us our reference angle is pi over 6 radians. And lastly, 5 pi over 4. Okay, well, think about this. We're going in a negative rotation, but just how much is 5 pi over 4? Well, halfway would be 4 pi over 4s, right? 4 pi over 4 is the same thing as just a 1 pi. So if we went 5 pi over 4, that means we went from here all the way around, and we would go 1 1/4 more. We would have gone 1/4 more, which actually is telling us our reference angle. Our reference angle there is just that 5 pi over 4. Take away the 4 pi over 4. That gives you that little remaining amount, which is a pi over 4 radian measure. All right, just about done here, guys. There's just a bit of terminology I want to leave you with. Quadrant angles. I was referencing them here in our margin. They are the angles that are on the angles in standard position that are going to be terminating on the x or the y axis. So if you are looking at a rotation that is actually not a rotation really at all, and you just are terminating here, boop, that is at 0 degrees or 0 pi radians. Then if you instead rotate and have a terminal side here, then that is at 90 or pi over 2. If you've rotated so that you have a straight angle like that, that is 180 or pi. And then last but not least, if you come and rotate this much, then that puts you at 270 or pi over 3. I guess not listed here is if you would have gone all the way around, which we can add that to our statement here. If you have gone all the way around, this is also 360 or 2 pi, right? If you would have instead gone all the way around, that would be 360 degrees or 2 pi, another quadrant angle. So that's it for this video, where we were looking at reference angles, finding those acute angles that are formed from the terminal side of our angle in standard position to the x-axis. If you guys had any questions about the content presented here, would you take a moment and share those now? And until next time, stay fired up.